Hello, dear aspirants. This is Dr. Saurabh Sir's classes. Our contact number is 9836793076. Again, I am repeating our contact number, which is 9836793076. So, our email ID is saurabhsirclasses@gmail.com. So, please feel free to contact us if you have any mathematical doubts, queries, or anything. So, please feel free to contact us. So, that will be beneficial for your preparation of upcoming examinations like ISI, TIFR, etc. In CMI, etc. So please feel free to contact us via these contact details. So you can join our regular batches or you can join our one-on-one sessions or online classes. So that will be beneficial for you. Okay. So now, okay. So now we are going to see the question. The question appeared in ISI MTech QROR in the previous year. Okay. And the question is telling us that for convergence of the given series, which is summation n equals to 1 to infinity 1 by x to the power n plus x to the power minus n, where our x is a positive real number. Okay. That means the given series is this. Okay. So now we are going to rewrite the general term. So the general term is of this equation of this series is equals to this. So then it will be what? A n equals to 1 by x to the power n plus 1 by x to the power n. Sorry. So we can write that in this form. So that will be 1 by okay. So my an will finally look like this. So as my general term is this, so we can write that as n tends to infinity. Let me change my font color so that will be easier to see. So now as n tends to infinity, now we are going to analyze the behavior of an for large n. So, so as our n tends to infinity and x, and let us take x greater than 1, then x to the power 2n plus 1 has to go to infinity. So my an is equals to what? X to the power n by x to the power 2n plus 1. So that will asymptotically similar to this. So that will be 1 by x to the power n. And that will be what? And so we can easily see that our a to the power n will go to 0 asymptotically as our n tends to infinity. And now for 0 less than x less than 1, then our x to the power 2n will go to 0. So our a to the an equals to x to the power n by x to the power 2n plus 1. So this thing will, okay, let us rest it. So this thing will go to 0. So we finally got what? So we finally got this will go to 0 and this will go to 0. So we will get 0 as n tends to 0. Okay. So the comparison test of the so now the comparison test of convergence. So let us compare an with a simpler term of to determine convergence. Okay. So observe the following cases. So now case 1, my x greater than 1, then what will happen? Then my x to the power n is tending to will tend to infinity, grows exponentially. Note that our a to the power a n is equals to x to the power n by x to the power 2n plus 1. That will be asymptotically this 1 by x to the power n. We got this in the previous step. So we can write that the summation of a n equals to 1 to infinity will be less than equals to 1, this n equals to 1 to infinity. Okay, so so this is a this is a geometric series with ratio r which is equals to 1 by x, and that is less than 1. So it converges. Then thus by the comparison test, the given series also converges for x greater than 1. Okay, so now we have to think about our x. Okay, so for the case 2 where our x is lying between 0 to 1, then what will happen? Then our x to the power n will go to 0. So will our an will go to 0. So summation an n equals to 1 to infinity, an will also go to 0. So we can easily see that this converges for 0 less than x less than 1. So after that, what can be done here? So we are going to take our case 3, then my x will be 1. So our x to the power n will be 1, and our x to the power 2n will also be 1. So our an is 1 by 1 plus 1. So that will be 1 by 2. So summation of 1 by 2 n equals to 1 to infinity, that which, so we can easily see that as this is a constant term and this is half, so that will diverge. Okay, so only for x equals to 1, so for only at x equals to 1 the given series diverges. So the series, so the given series which is n equals to 1 to infinity 1 by x to the power n plus this converges converges for x belongs to r plus minus 1. Hope you understood. And again, I am telling that if you have any mathematical query or if you have any doubt, so please feel free to contact us via this contact details so you can enjoy all the services of Dr. Saurabh sir's classes. Okay. Thank you guys. Hope you understood. Thank you.